Well, welcome students to the scientific method. This approach to garnering or getting data that is valid and reproducible is really the hallmark of the scientific method right here. The problem with the term scientific method is that everybody assumes that only scientists know about the scientific method and it's only used in research labs. That couldn't be further from the truth. The scientific method is a method by which you arrive at conclusions that, quote, are valid and hopefully reproducible. That can be trying to understand what controls the heart, what are the factors involved in controlling the heart, or it could be in how to make a good beer, or how to fix your car, or how to put makeup on. The only difference is some of these are written up and published and others aren't. But the thinking behind it is somewhat similar in all cases. So don't think, oh, I got to learn the scientific method whenever I do science. Guess what? I'm never going to do science, so I really don't have to understand this. Nope, it goes on all the time. It's just called, another way of calling it is really problem solving. You're solving a problem. And that problem could be anything, as I mentioned a minute ago. So in the steps we have listed here, we go 1, 2, 3. Okay, I'll check it for 1, 2, 3, 4, 5. They sometimes go in order. Sometimes you might actually do observations, hypothesis, and things. Actually, you're going back and forth between the two. So it's an observation that triggers a question. I think that's could be the case, but it could be that you really want to know how to make that car go faster, or how to program something. You maybe are already here, and you're looking at observations of things around that might be able to help you. So it can go both ways. And then in this work, and what makes this presentation so germane is you have to do a literature review. And in the past, whenever we'd say the literature review, students would run because they say, oh my God, I have to go to the library. Oh, gee, I don't know if I want to do that. Now, what most of you do is you go to the web. And the web is really another method of literature review. But the literature review is talking about scientists who have done similar work, or a mechanic who's done similar work, or somebody who's used Photoshop. And so you're saying, how do you make this work on Photoshop, or what do you do? It's a literature review in the sense you're finding out what other people do. So in science, we do the same thing, which means when we're looking at how the heart works, or why we need oxygen, what's the data to show that we evolved, you go to the literature. The point about the literature here, and I'm sure you've seen this also when you've done your own work on the web, some sites are more reputable than others. Some might be from 2 or 3 people who've done research in this area and say, the best way to do this is X, Y, and Z. In many cases on the web, it's one person. One person is fine, but that doesn't mean too much unless that person really is conversant in the area. So if you're looking at a scientific paper, you want to have that paper reviewed by other scientists who are in the field, who say, this data here is credible because it's valid, it follows certain pathways, and it's reproducible. That's what literature review is all about over here. So if someone is making some kind of claim that he or she can increase your biceps, to a diameter of 30 within 45 days by taking steroids, by taking protein supplements, by lifting weights 4 times a week or something, then you have to go to the literature and say, what, is this really right? And that's what we do in science. Then in science, just like you, we do experiments. And the biggest point about experimentation I want to bring out here is we have control groups and we have experimental groups. C&E, the control group, is a group with which we don't do anything to see if we have somewhat the same kind of effects that you do with the experimental group, or you control it, you take out a variable. So in the case of the weightlifter study, you can say, well, one group's going to take steroids, and also that same group's going to take protein supplements, and it's also going to lift weights 4 times a week. the other groups, the other experimental groups, are going to be one that just takes steroids, takes the same amount, etc. The other one's going to be the group that takes a protein supplement. And the other group is going to be the one that just lifts weights, I think. What I'm getting at is you have to break up the component parts. And the ultimate control is, in some cases, doing nothing. The person's just normally living. How much do these different experimental factors play a role? Once you gathered your data, it has to be analyzed, and you have to come up with some conclusions. So it's best to have control and experimental groups so you can compare the two groups, right? So if you have one group of elderly people that walk 6 miles every week and another group of elderly people that don't walk at all, then you find out that those who don't walk at all, they don't die any sooner than those who do. Then the 6 miles per week really didn't help them in terms of longevity, if that's your question. So you have to look at analysis and conclusion in the light of what's going on with the controls and experimental groups. Finally, once you've done that, you then refute, which means you either say, nah, that data didn't support my hypothesis, or it did, whatever my question was. Now, what becomes important with this is that going through this process, and if your hypothesis is supported or not, you've at least come up with some solid data that's valid. Your experiment might have been negative. Well, it turns out that all you have to do is take the protein supplements and your biceps will grow bigger, or you just have to lift weights. So you have to be very careful about this, but then you have some valid data. And then the point is, because you've done the experiment with controls, you then can theoretically have it reproduced. And the biggest problem, as I mentioned in the chapter, is reproducing the experiment, meaning you have to go through and do all that. It's very time consuming, very expensive. In some cases, people basically say, well, we already knew that. Why did you do that again? But reproducibility is right up there with having the data be valid. The scientific method, and I mentioned in the chapter, there's a non-scientific method, which means they don't have controls, no controls. Well, there are experiments or observations that go back hundreds of years or thousands using acupuncture. Acupuncture, putting needles in the ear, minimizes a headache. Well, where's the control? Well, we don't have any controls. The control would be somebody who had the same headache, and you watched him or her at the same time to see if the headache went away just as fast or faster than, or had no change relative to those who had the needles in the ear. You need to do controls. That does not mean that acupuncture, needles in the ear, might not play a role in terms of activating sensory nerves, etc., etc. You just don't know. So to me, the non-scientific method is not to be something you say, well, there's nothing here. Look, it's been going on for thousands of years. There must be some validity there. Or maybe the subject just believes it's going to work, and it works. So you have not only the scientific method, you also have to take into account the subject. If it's a human and you're looking into pain moderation or different issues, it becomes very complicated because a human subject will try to please the investigator. So this is why controls are always very good. But again, if that's been going on for hundreds or thousands of years, is there some truth to taking that herb from a jungle in Mexico and cooking it and coming up with something that can help the person relative to some disease? You don't know until you do the experiments. Hopefully this helps and gives you a better idea of why this is the basis of use. Stepping back when somebody says vaccinations are lethal or are going to hurt your child, you have to take a look at the literature. Don't look at just one person's article. Make sure his work or her work has been peer-reviewed before you make any decisions. It's the same thing with global warming. Well, there's 3 or 4 persons who say global warming is not due to human factors, and there's maybe 10,000 who say it is. Well, you have to begin to look at what's going on with a majority of scientists who are looking at that area and consider it from that point of view. This area of you becoming critical thinkers becomes more important because you'll be doing a lot of this on the web yourself. So be very careful and very cynical and critical as you read different articles. Thank you very much for your time. Have a good day.